Today I'll be discussing Java Completable Future API and how it is different from the reactive landscape where we have reactive streams. So how it is different from the completable future, and both of the cases basically helps with asynchronous programming. So this article which you're looking at right now is a very good article which shows what are the differences and how all of them fit in the reactive landscape. So you can see what is the Java Completable Future API. So the Java Completable Future API is standard Java API for asynchronous programming, and it was introduced in Java 8 in 2014. Its predecessor, which is future.get, so it is basically a blocking call, but the Completable Future API is not a blocking call. And the Reactive Manifesto, it's a different thing altogether, which was published in 2013, and the version 2 of it was published in 2014. So it takes this asynchronous programming one step further. So you can see this is one picture which basically give the idea when all the different concepts came into being, and when the JDK implementation of Computable Future API or the Flow API was introduced, and all other things were introduced in this timeline. So talking of Flow API, it is basically a Java 9 feature for the reactive streams. You can look at this para which says inspired by the manifesto which we are talking about. So this is reactive manifesto which we are talking about. The reactive streams projects define the interfaces for reactive streams in Java 1.0 released in 2015. Later on, reactive streams got standardized and included into JDK as the Flow API as of Java 9. So this reactive streams was introduced, which is a specification basically, as you can see, around in 2015, but later in 2017 in Java 9 in JDK it was published as a Flow API, which helps with the reactive programming. Notice that both reactive streams and Flow API just provide the interfaces. It is up to the reactive framework like RxJava or the project Reactor to provide the actual implementation. These two concepts make up most of the asynchronous programming landscape in Java today. So it is talking about two concepts. What are two concepts? The Flow API and the reactive streams. So Flow API, which was introduced in JDK 9, and reactive streams, which was introduced in 2015. This is part of JDK, and reactive streams is a part of, it's mostly, you can say, it's a specification, and the frameworks like Akka streams, project Reactor, RxJava, it all make use of this reactive streams specification. We will now compare Computable Future versus reactive streams. So you can see the Computable Future represents one result of an asynchronous call. So it clearly states that if we are interested in getting one result, we can go for the Computable Future. While the reactive streams is a pattern for pushing n messages asynchronously through a system. So if we want more than one, then we can go for the reactive streams, which is a continuous flow of messages. Therefore, Completable Future does not and could not address the elasticity requirement of the reactive manifesto. by providing back pressure. So this back pressure basically is a part of reactive streams which is used in Java reactive frameworks to provide the reactive features. In computable future, this back pressure was not available, and that's why it could not handle the elasticity requirement of the reactive manifesto. Any framework which addresses this elasticity requirement of the reactive manifesto will be able to handle the reactive flow of the messages. For any reactive streams implementation, on the other hand, back pressure is a central concept. Let's talk about what problem does asynchronous programming solve. So why we are talking about this asynchronous programming at all? Why we are interested in it? Using computable future or using the reactive streams. Why to use all those things for using asynchronous programming features? So you can see, as we are moving from monolithic architectures to the microservice architectures, there are chances that when we are making call to another microservice, there are chances that there will be network latency, and it is not making sense that we block the server thread until we get the response from the other microservice. So till the time the result is not available from another microservice, that thread can do some other work. So this feature can be handled by asynchronous programming using computable future or the reactive streams. So that's why we go for the asynchronous remote server calls, or we can say any asynchronous architecture. So it basically helps us to make use of the threads most efficiently, that it will not be blocked and it will be doing some other work till the time the result is not available. And the other thing we can see, all the industry applications are moving to the cloud, and we know if we are not making use of the provided resources of a cloud instance, then we'll have to spin up multiple instances, and this way will be charged more by the cloud provider. So it's better to make use of whatever available instances we have to serve more and more users, and we can do that only when we have asynchronous programming features where one thread can be used to do more and more work, and that thread will not wait till the result is available for any microservice call or any database call or any such blocking call. So till that time that thread will not be waiting for it, and it will be doing some other work. So that way we can make use of threads more efficiently, and we can make use of the available instances more efficiently. Now we'll discuss when to use Java computable features versus reactive streams. So as stated earlier, the computable feature basically helps to serve one request at a time, but reactive streams basically helps to serve multiple messages. So what it says about the scenario one is single calls to microservices. The big plus of the Java Computable Future API is that it's relatively simple and available out of the box, which is why, because it is part of the JDK. When you can call a remote microservice or a slow database to retrieve a specific result to fulfill the current request, it's probably not the place to use a reactive stream. One result is all you ever asked for. You are much better off using the methods in the Computable Future API to add a custom callback, specifying what to do with the result once it is ready. In the other words, this is a perfect use case of the Computable Future API. Example scenario could be when you need to fetch invoices from two different remote systems. then combine the results and take some action on the outcome, for example shown in the UI. A second scenario is a stream of asynchronously processed data. So we are talking about a stream now here. On the other hand, imagine a scenario where you are truly operating on a stream of messages. Let's say you have a SMS gateway that receives SMS messages as they come in from users. Each message needs to be processed by SMS processor, which is a remote microservice and contains a command that takes variable time to execute. You could implement this scenario based on CompletableFuture API as well, but then you would be reinventing the things like back pressure. What if SMS processor is overwhelmed by previous messages and not yet ready to receive more data? Such streaming scenarios are much better taken care by the reactive streams approach implemented by frameworks like RxJava or Project Reactor. In short, there are use cases for both approaches. Single asynchronous operations where CompletableFuture API helps to keep things simple, and true streaming scenario where you will be want to use reactive streams. So that's all about this discussion. See you next time.